question 6, we have a scenario where City Council wants to estimate the population proportion of adults who favor gambling. And they want to find the most conservative estimate of the sample size so that the margin of error is 0.05 or 5%, and our confidence level is 95%. So let's write down all of that. So we know that our confidence level is 95%. We want to make a 95% confidence interval, and we want such that our margin of error is 0.05. And we want the most conservative estimate of the sample size, so we want to find n so that all of these things are true. So as a reminder, how do we find our sample size given the margin of error? So if you remember, for when we're making a confidence interval for the population proportion rather than the mean, our margin of error is equal to our z-score corresponding to our confidence level times the standard deviation of our sample proportion, which, if you remember, is our proportion times 1 minus the proportion divided by n, take the square root of the whole thing. So I can use this formula, but since I want to find n, I want to solve for n, I'm just going to rearrange this to make this easier for myself. So I'm just going to do some simple algebra and rearrange this so that I have n by itself on one side, and if I do that, I'll get n equal to z squared times p times 1 minus p over the margin of error squared. We know our margin of error, we want it to be 0.05. And I know that my confidence level is 95%. We found the z-score a lot in the previous question, so I'm not going to go through how to do it again. You can look at the other videos where we've done this to see how I find a z-score of 1.96 for confidence level of 95%. Then I need p. Well, the problem is, if you notice here, it doesn't give us a sample proportion. It just tells us that we need a certain confidence level, certain margin of error, and it tells us we need to find the most conservative estimate of the sample size. In other words, when I'm talking about a conservative estimate of the sample size, I want to err on the side of caution. I want to have more people than necessary rather than too few. So I want to make my n as large as possible. Given these other two conditions, I want to be really safe and conservative. I want to have more people than I need. So that means I want to pick a proportion such that I make this n really big. And you can experiment with this on your own, but to maximize the quantity, p times 1 minus p, and you can try it out yourself. You can try 0.7 times 0.3, for example, 0.6 times 0.4, 0.55 times 0.45. What you'll find is that the value of p that maximizes that is 0.5. And 1 minus 0.5 is 0.5. So in other words, I was instructed to make the most conservative estimate of our sample size as possible. I want to pick more people than necessary, as many as possible, given my confidence level and margin of error. So we weren't given a proportion here. So I picked the proportion that would yield me the most conservative sample size, the one that would give me the biggest value here, which was 0.5. So now I can plug all this into my calculator. So I plug in 1.96 squared times 0.5 squared divided by 0.05 squared, and you should get 384 0.16. Remember, whenever we're dealing with the sample size and number of people, we don't want to use a decimal. We always round up. So we get 385. So we tell the city council, make sure you pick 385 people for your study.